Okay, we're back. So you see from the table, 2 pounds per barrel of ale times the number of barrels, 3 pounds per barrel of corn in a lager, it's 3Y, 2 pounds per barrel of hops in the lager, 2Y, 2 pounds per barrel of hops in the ale, 2X. Therefore, we have these two constraints, plus we all know that our number of barrels must be positive. So let's erase this, and we will do step 3. So just to keep my thing straight, I'm going to put my objective function here. Okay, so step 3, find the x and y intercepts. Okay, let's take the corn constraint, 2x plus 3y, and we make that an equality, 1200. Okay, so I am on page 5 now, and y equals 0, that's 0, so 2x equals 1200. And x equals 600. All right, so that point is going to be 600 and 0. Now, when x equals 0, I'm going to get 3y equals 1200. So y equals 400. So what we're going to have here is 0 and 400. Okay, now the second constraint equation, 2x plus 2y, let's make that an equality. When y equals 0, 2x equals 1,000, so x equals 500. So that gives me a point of 500 and 0. 500 and 0. Now when x equals 0, 2y equals 1,000. So y equals 500. That point becomes 0 and 500. All right, so my next step 4, is to find the intersection points between these two equations. So, got to solve systems of equations here. So step 4, find the intersection points. So we have equation 1, which is 2x plus 3y equals 3,000. Not 3,000, 1,200. 2, 2x plus 2y equals 1,000. What I'm going to do here is it's a really simple solution is multiply both sides of equation 1 of equation 1 by minus 1. So that gives me minus 2x minus 3y minus 1,200, and I'm going to add that to the second equation, 2x plus 2y equals 1,000. These cancel. I got minus y equals minus 200 multiply both sides by -1, and y is 200. That's 200 barrels. And that's of lager, I believe. So now to find x, I'm going to substitute y equals 200 in equation 2. So 2x plus 2 times 200 equals 1,000. 2x plus 400 equals 1,000. Bring that over there. 2x equals 600. And x equals 300 barrels. And I believe this is ale, and this is lager. So that's my intersection point is 300, 200. So what I'm going to write down here is my intersection points that I have, so I can carry them over. I have 600 and 0 and 0, 0 and 400, and that's equation 1, that line. And I'm sorry, that's equation 2, I believe. No, that's 1. All right, and I have 500 and 0, and 0 and 500. That's the line equation 2. And as an intersection point, I have 300 and 200.
Now, are those all called intersection points, or is only the fifth one called the
Only the fifth one is called intersection points.
So what's the set of them all called?
These are x and y intercepts.
Okay, they're not called like extremes or anything like that? Or
No, these are intercepts.
Okay.
I'm just using they're extremes for the first quadrant, but they're intercepts. All right, that's what everybody understands. Yeah, we're not talking about extremer and things like that.
I thought you called them all intersection points at one point.
No, intersection points are intersection between these two.
Sure, so there's
Yeah.
only one
Well, they
of
do
them.
intersect with the x and y
Well,
axis.
sure, yeah.
But that's what the x and y intercepts do.
Right, yeah. So these are potential
These are potential solutions.
Right.
So now I'm going to graph this. But what I'm going to do is I'm going to write this as a linear programming problem first, because this is what they're going to ask you to do. So how would you write this mathematically? Which I should have done before, but this is my math representation. Is to maximize P equals 30x plus 35y, subject to these constraints. And once again, 2x plus y plus 3y, I'm sorry. 2x plus 3y is less than or equal to 1200, which we developed from the table. 2x plus 2y, 1,000 pounds. That's the way I express my problem. From that, I developed my x and y intercepts from each one separately, and then I solved these as a system of equations and got where the two lines intersect. Now, if these were two parallel lines, there'd be no intersection. You'd know you actually developed your problem wrong. So let's graph this now. Since we're really talking about a graphical solution here, let me see if I can get that line a little bit straighter. And this is point 0, 0. All right, let's look at the first equation. Well, I'm gonna bring this to 100, 200, 300, 400, 500, 600. Okay, what about the other side? Well, 100, 200, 300, 400, 500. Let's get the first one. 600 and 0, that would be here. And 0 and 400. Let's connect those points. That's going to be the first straight line. That's why it's called linear programming, because we only deal with straight lines. Now the second one is 500 and 0. And 0 and 500. Let's connect those two. Here's your intersection point. And your intersection point we know is 300 and 200. Now if we look at these, the one closest to 0 is 500 and 0, so I put a big dot there. I'm going to count all intersection points on our thing. And the closest to 0 on the y-axis is 400 and 0, making this region here called our feasible region and our convex set. Now you might wonder what happens to all these points in here? Well, if I had time, I could derive why the maximum is always at one of the corner points. If this is what they call a convex set, the maximum of the objective function will always be found at one of these corner points or feasible points. So the next step, and then the last step, is to develop my chart. Okay, I'll leave the graph on the board. And the next step is to develop my chart. This is my comparison chart. So step 5, I believe, your comparison chart.
We're at the 13-minute mark.
Almost finished. I don't know. Will you buy this?
I don't know. I think that the videos that were slightly longer than 15 minutes uploaded.
So this
no
is
problem.
feasible corner points. Let's write it like this. I think there was some slippage, wasn't there?
Yeah.
Feasible corner points. And the objective function. Maximize P equals, I believe that was, I took it off the board, but it's 30x plus 35y. I'm not going to do 0, 0 because that's ridiculous. So I'm going to do the other points, 500 and 0, 300 and 200, and 0 and 400. So what do we do now? Well, P equals 30 times 500 plus 35 times 0. Let's just write them all out. P equals 30 times 300 plus 35 times 200. And P equals 30 times 0 plus 35 times 400. Okay, so for the first one, when we do it out, we get $15,000. When you do this one out, you get $14,000. And this one is $16,000. So what's your answer? So our answer is, let's get rid of this now. And this is what they're looking for. So our solution is basically to produce x equals y equals, all right, 300 barrels of ale, $200 barrels lager to make a maximum profit equals $16,000. Okay, this last problem is exactly what you're going to get on your final. I would tell you to go over this, try to solve it by yourself. I will give you a problem in class to do as an example, which you can do in class, but you do have one on your take-home exam, almost exactly like this. And this pretty much covers linear programming, the graphical solution.